Most of the films shown here were collected together at the Marconi Research Laboratories at Great Baddow for the purposes of Dr. Eastwood's Appleton Lecture. Many unwanted effects can influence radar performance, and these films illustrate some of them. Data from an S-band long-range radar situated at Bushy Hill near Chelmsford was used for this first set of pictures. The pictures shown are taken by a system called Time-Lapse Photography. In this system, a cine camera is mounted in front of the PPI screen, and then one frame is exposed for one complete turn of the radar before being moved on to the next frame. Hence, when played back, one can see several hours of filming of the radar compressed into a very short space of time. You can see all the targets running around on the screen, and in the centre, the very bright area is caused by clutter from nearby objects to the radar. The dark circle in the middle is where the operator has turned off some of the clutter to save himself being dazzled. There is some weather information shown on there, and you can see on the left hand side some cloudy effects which are caused by rain sweeping across the area being viewed by the radar. You can see the range of the radar also with the Dutch coast on the right and the west coast of England on the left. This recording was taken from a 600 MHz radar situated in the middle of the London Airport TMA area. You can see the aircraft flying up and down the air lanes shown by the map, and also you can see them landing and taking off from the centre. This radar was the right machine for the job, and because it worked at 600 MHz got rid of nearly all the clutter. Here's a closer up view of the same picture. You can see more clearly now the aircraft flying in and out of the centre. This radar, unfortunately, now is not able to be used because it's in the same band as the VHF band of television, and it interfered with it. However, this radar gave the operators a very good picture of the air activity around London Airport and contributed greatly to the safety of the system there. Many natural phenomena affect radar, and one of these is the Aurora Borealis, which is ionized air produced by the sun. This, of course, reflects the radar beam back and gives rise to the stripy lines that one can see emanating from the centre of the radar picture. And here we see more effects of the Aurora Borealis on a long-range radar. Another natural phenomenon that caused great problems for radar was anomalous propagation. This is where there's an inversion layer in the atmosphere and the radar beam gets bent down back into the ground, to such an extent in fact that it goes right over the horizon. In this case you can see clearly how it's picking out the coast of East Anglia. It's also seeing the French and Dutch coasts, and up in the top right hand corner there is a second time round echo, as it's called, where the beam goes round and back twice, and we can see the coast of Norway up there even. This was a very, very unusual situation and was filmed at Baddow, I think in 1962, and it was quite one of the most fantastic examples of anaprop that I've. And of course it's virtually impossible to see any aircraft through the clutter. This big storm in August 1962 also produced an enormous amount of rain, which you can see falling over the coast of northern France, just over the channel there. Again, this is heavy rain over England, over the area that we're really looking at, and it's appearing more or less in the centre of the tube this time. Heavy rain also develops to the west and the northwest of the radar. Heavy snow also causes a great deal of clutter on radar. Here is a picture taken over London Airport, and one can see to the west there aircraft stacking who are held up to try to get into the airport by the snow. One can see the occasional one peeling off to go to the centre. Here we've turned on the MTI system, which has got rid of most of the clutter, and unfortunately, as frequently happens in this case, we get rid of some of the aircraft as well. This is a small price to pay for the clarity though. The ability of radar to see cloud and precipitation, however, is not always a bad thing, because it can be used, particularly in aircraft, to look out for storms. Here's the nose of an aircraft with a small radar in it, scanning backwards and forwards looking for storms and clouds. These radars are quite short wavelength, so they're very well affected by storms and precipitation. Inside the cabin, the pilot has a view that looks like this, and he can see, looking ahead, where the storms are and fly around them, making the passenger's journey much more comfortable. This next sequence was taken in America and shows the effects of a huge storm on the radar. This radar was in fact a weather radar looking for poor weather, and one can see the cloud and precipitation swirling round the area in the bottom right of the picture. This is quite a long sequence, and one can see later on in the sequence that the Americans, being very interested in how the storm was made up, sent an aircraft up to buzz around in the eye of the storm to try and gain meteorological data. There are very few aircraft shown on this radar other than the one, as you can just see, going round in the centre of the storm. I think it's quite difficult to know whether the pilot was brave or foolish. Deliberate clutter can be caused on radar during military exercises or under military situations by dropping what's known as window. Window are thin strips of aluminium foil tuned to the radar frequency, and they produce very heavy clutter which masks targets and raids. It was used very frequently during the last war by the Germans against us, and vice versa. And lastly, we come to the phenomenon known as angels. In truth, all birds are angels, but not all angels are birds. In other words, there are still some mysteries that remain on what some of the targets actually seen on the radar are. In this case, though, it's virtually all birds, flying north in March towards the poles for the winter. Here is a height finder looking at the birds, and also there are some aircraft. The birds are the rather fuzzier blob, fairly close in the middle of the other targets, which are in fact aircraft. Here we have birds again, different time of the year, flying southwards this time, pouring across the country, producing huge interference on the radar. Here they are all going south. Here are more birds in a slightly more interesting situation. We have rising air with insects going up with the rising air, and the birds then go up and pursue the insects and produce these lines of interference as the insects all fly up and the birds go up after them. Here's an even more striking example of this. We had 2 or 3 warm fronts proceeding across England, the insects being taken up on the warm front in the warm air, and all the birds going along and going up into the warm front and producing these lines of interference on the screen. As can be seen, these birds are a very big hazard to the radar and have a very bad effect on it. This is lastly a very strange phenomenon known as ring angels, and it mystified everybody for some while. If you look at the left hand side of the clutter area, top left, you can see rings forming, rather like throwing stones into a pond. Somebody was sent out there in the end, and he sat there at dawn. You can see the sun coming up over there in the east, and eventually they were found to be millions and millions of starlings flying away from their roosts in the morning. This film shows some of the phenomena that affect radar performance.